So you've probably seen this formula before. It is an infinite formula for e. It is 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial and so on and so forth. And it's a really cool formula, the fact that it works. And you probably, if you did derive it, if you've ever seen someone derive it, they probably use the Taylor expansion because it's the easiest way to do it. You just find the Taylor expansion for e to the x, which is easy. Derivative of e to the x is e to the x. And then you just plug into this formula, set x equal to 1, and you get this. But there is another way to do it that doesn't even need to use the Taylor series. We can just use this definition for e over here, which you can get from, I think, one way to get it is by setting the derivative of e to the x equal to e to the x, and then using first principles, and then eventually you arrive at this limit by making a few substitutions, so on and so forth. Maybe I'll make a video on that soon. It's not that difficult though. So let's just get on with it, okay? And the main objective here is just to use the binomial expansion. Okay, you can see that's the binomial expansion right here. So let's go ahead and make use of it, right? E equals, we're going to keep the limit there, that's important, but we're going to use our binomial expansion. And it's very easy to use a binomial expansion because our leading number here is 1, okay? Our little number here is 1, so it's going to make it very easy, right? The first term is going to be 1, because that's what it always is. And then the next term is going to be, if you remember, it's going to be 1 over u times u, right? It's going to be u times by 1 over u, okay? That's what it is, right? That's a binomial expansion. And then we're going to keep going, right? We're going to go u, okay? And then we're going to have u minus 1 over 2 factorial. That's kind of using our little choose, function here. And then it's going to be times 1 over u to the power of 2. Right, so we can write 1 over u to the power of 2 is just 1 over u squared. And then so forth. I think it's a pretty straightforward thing here. I think we'll stop here for now. Okay, I'll zoom out and then so on, right? Oh yeah, sorry, I forgot about that. 1 over u cubed, that's important. There we are. Okay. So that's what we get. We expand it out. So let's have a look at the first few terms, and then we can maybe arrive at some kind of conclusion. So 1, well, that's 1. U over u is also 1, okay, even if as the limit approaches infinity. And then here we're going to get this. Let's expand this out. So we're going to have u squared minus u over 2 factorial times 1 over u squared. Plus, and then here we're going to expand this one out. It's going to be what? U cubed, definitely u cubed. That's going to come in important later. And then we're going to have minus u squared. Yeah, wait, u. Okay, minus u. And then we're basically just timesing this by that, right? So what do we get? So we get u cubed times by minus 2u squared. Minus u, minus u squared again, so it should be, I think it's minus 3u squared. Sorry about that, and then plus 2, right? All over 3 factorial over 1 over u cubed, that's so on and so forth. Okay, there we go, we got that done. All right, now the rest of these terms aren't important. I'll explain why in a minute. But let's just have a look at the first thing. Let's see what cancels, because a lot of things cancel. So the first thing that cancels, as we can see here, is the u squareds. Right, the u squareds cancel, and we're just going to be left with 1 minus 1 over u over 2 factorial. All right, and then we're going to go plus so on. So let's have a look. The u cubes as well cancel here. It's going to have 1, and I think you're going to notice this because the order of this polynomial here. The order of this polynomial, or the highest, so the highest power of u is always going to be whatever this power is over here. Okay, so if this is n, if this order is n, this is going to be order n as well, which means that we're just going to always be left with 1 minus a bunch of stuff. So let's have a look at this stuff. This is going to be minus 3 over u plus 2 over u cubed over 3 factorial plus so on and so forth. And I can say pretty confidently, right, that if I keep going, with this, I'm just going to get plus, and then a 1 over, let's say 4 factorial, And I'm just going to get plus a bunch of stuff, right? And all that bunch of stuff is just going to be a reciprocal of u, maybe to some kind of power, right? Like we can see here. But it's definitely because this is going to be the highest order, okay? Everything else is going to be a smaller order. This is all going to be 3u squared. And then, for example, here you're going to have maybe 3u cubed, so on and so forth. It's going to be a lower order than that. So it means it must be smaller. You can see right here, it's all a lower order, okay? So I can be confident that's all just going to be 1 over u to the something, okay? I'll put a little box like that, and so on and so forth. Now, if that's the case, then that means with the limit, right, as it goes to infinity, as this goes to infinity, the whole thing goes to 0, right? I think you should be pretty confident with that, right? 1 over a really big number is a really small number. So you're just going to be left with that. So eventually this all cancels out, and what you're left with just, well, 1 plus 1, and then 1 over 2 factorial, over 1 over 3 factorial, plus 1 over 4 factorial, and so on and so forth. And there you go. You have your formula for E over here. Didn't even use Taylor expansion. All it is just a little bit of binomial expansion. I think that's pretty cool. So yeah, thank you for watching, and I'll see you in the next one.